So for my video, we are going to be looking at extrema of functions of two variables. In this question, we're given the function f of x and y equals x squared times y plus y cubed minus 48y. So the problem has already given us 5 critical points here. Our goal is to test these critical points so that we can classify each one as either a local maximum, a local minimum, a saddle point, or we can say that the test is inconclusive and it doesn't tell us what's happening at the point. Okay, so in order to test each of these points, we have to get our second order partial derivatives. And to do that, we have to start off by getting our first partial derivatives. So we're going to take the derivative with respect to x, where we treat y as a constant, and that will get us 2x times y. And next, we have to take the derivative with respect to y, where we treat x as a constant, and that you will get x squared plus 3y squared minus 48. Now that we have our first partials, we can get our second partials. We're going to take f sub x of xy. We take the derivative of f of x, this function, with respect to x, which you're going to get 2y. Now we're going to do the same for y, f sub y of x and y. It's going to be the derivative of this function with respect to y. You're going to get 6y. Now you're going to take f sub xy of xy. This is, you're going to take the derivative of this function with respect to x. You're going to get 2x, just 2x. Now, in order to test each of these values, we have to use a formula to get the value of the discriminant. And that formula is d of xy equals f sub xy times f sub y times xy minus f sub xy of xy squared. Okay, now we're just going to plug what we got over here, into this formula. So we can rewrite this as d of xy equals f sub xx is here, 2y, f sub yy is 6y, minus f sub xy squared. You'll get 2x squared, which simplifies to 4x squared. So, and this simplifies to 12y squared. So that's our formula. Now what we're going to do with our formula, oh, that's not nice. Okay, now basically what we're going to do with our formula is we're going to take all of these points over here and we're going to evaluate it with this function, with this being your x and this being your y. So let's start off with this first one. D 4 rad 3 0. I'm going to plug into the formula. 12 times 0 squared minus 4 times 4 rad 3 squared. We know that this part is going to be equal to 0. And here, let's evaluate inside first. 4 squared, you're going to get 16. Rad 3 times rad 3, the radicals cancel out. You're just going to get 3. Now, let's see. 16 times 3 is going to be 48. And 48 times 4, negative 4, you're going to get negative 192. So here your d of 4 rad 3 0 is going to be negative 192. Now, when your discriminant is less than 0, which negative 192 is, you will get that this is a saddle point. So here we can just write that here. F has a saddle point at 4 rad 3 0. Now that one's done. Nice. Now let's evaluate the second point. D of 0 0. You're just going to get 12 times 0 squared minus 4 times 0 squared. And you get 0 minus 0. D of 0 0 is 0. Okay, so now you would probably write, oh, like this is inconclusive, right? But we have to remember that this second partial test only works on actual critical points. So let's test if this is a critical point. So you're just going to plug in the points into your first partial, which you're going to write. So here, f of x, let's just replace that real quick. 0 0, right? F of x is 0 0, you're going to have 2 times 0 times 0, which is 0. Okay, that works. Now f sub y is going to be 0 squared plus 3 times 0 squared minus 48. That you'll get negative 48, which is not equal to 0. It's not equal to 0. That means you can't even use the second partials test because 0, 0 is not even going to be a critical point. So it's not like a real critical point, meaning that you just put not a critical point, which they have it just like that in the web work as well. So that one's done. And now we're going to move on to the third one. Oh, so d of 0, negative 4 is going to be 12 times negative 4 squared minus 4 times 0 squared. 4 squared is going to be 16, and 4 times 0 squared is going to be 0. 12 times 16, you're going to get 192. So there you go. And 192 is greater than 0. When your discriminant is greater than 0, we will know that you have two options. It's going to be a relative maximum or a relative minimum. And now in order to test that, we have to test f sub xx at 0, negative 4. So remember our f sub xx formula is right here. So let's test that. It's going to be 2 times negative 4. It's going to be negative 8. Now since negative 8 is less than 0, your function is concave down, meaning that this point is going to be a relative maximum at 0, negative 4. So here, let's write relative maximum. So that's something that we should know. Okay, boom. Now that one's done. Let's do our final 2 points. D at negative 4 rad 3, 0 is going to be equal to 12 times 0 squared minus 4 times negative 4 rad 3 squared. We evaluated something similar to this earlier. It's going to be 0 minus 4 times, again, 16 times 3. It's going to be 48. So let's just write here. This is going to be equal to negative 192. And we get that this is the same as this one, which also means that it's a saddle point because it's less than 0. So let's write that here. It's a saddle point. Or we can just write like, oh, it has a saddle. Like, it's the same thing. And okay, and our last point is going to be d is 0, 4, 12 times 0 squared minus 4 times 0 squared. This just becomes a 0, and this becomes 12 times 16. I think we got that earlier. 12 times 16 is 192. 192. Okay, again, we have to evaluate this with f sub xx like we did here, and d is greater than 0. Also, 0, 4, our f sub xx is right here. So I'm going to do 2 times 4, it's 8. Now we got that since 8 is greater than 0, this is going to be concave up, meaning that this value is at a relative minimum at 0, 4. So here we can just write relative minimum. Okay, cool.